Right, hi everybody. Can you hear me good? I think so. Thanks for coming to my talk. I'll be talking about writing Unreal Engine commandlets for fun and profit. A bit about myself. I'm a lead programmer here with these guys. 11-bit Studios, you might know us most recently from Frostpunk, and a little bit before that, This War of Mine. We're a company of 200 devs or so, or more, I guess. We have 3 internal projects running right now and a couple of others in publishing. I'm a programmer with 15 years of professional experience. I've joined the game industry working mostly on game services 10 years ago. I was the lead programmer for GOG Galaxy Client application. We did a little bit of backend work with The Witcher 3 and with the Gwent guys especially. Later on, I joined 11-bit Studios to help with the last DLC for This War of Mine, Fading Embers. And now I'm working on this thing. So it's The Altars. It's a sci-fi survival base builder thing, I guess. You're playing as this guy, you're trying to survive, and the only way to do that is to create alternative copies of yourself. I must say I really like this artwork. I have 3 kids, and I can totally relate to this guy in the middle. Onwards to some more fundamental questions. Why are we here? So what's a commandlet? What's that thing that was in the title? It's a pretty simple concept, actually. It's a command line extension for Unreal Editor, or at least that's one way of thinking about it. It allows you to run your Unreal tooling code inside of any CI/CD pipelines. It allows you to, modify assets like that or resave them. An alternative way of thinking about it is this is a command line front end, command line interface for your editor tooling code. Here's some examples of commandlets you can find in vanilla Unreal Engine. The most common one, I think the one that people actually use the earliest, even maybe without knowing about it, is the cook commandlet. If you ever cooked a game build in Unreal, you already use the commandlet. There's other useful stuff. There's the resave packages commandlet. It will resave any assets that you order it to do. That could be used to fix up redirectors, for example. There's stuff like the data validation commandlet or compile blueprints commandlet. You can use them. To check the quality of your commits, of your data, of your assets. There's the diff assets commandlet. You can plug that into, for example, P4V, into your to your source control tool to visualize diffs, for example, to diff blueprints. Whether that's a practical thing, that's a different question. There's something called the gather text commandlet, which does a ton of various localization work. There's even a file server commandlet. So you could use it to host a file server using Unreal Editor. I don't know why you would want to do it, but it's a thing. Since this is a pretty technical talk, we'll need to focus our attention a bit on the technicalities that we're using. The Unreal version I'll be talking about mostly is Unreal Engine 5.1. I know 5.2 got released like 4 days ago, something like that. So I don't think it's usable yet, not for me at least. A lot of stuff that I'll be showing changes rapidly, especially changed from version 4.27. The code that I will be showing was actually originally written on 4.27, and then I had to migrate it. I assume everyone knows how to write custom C++ code in Unreal. I'll be skipping stuff like includes or error handling for the sake of brevity. That's stuff that you can, I guess, add on later on your own. I assume everybody will understand the basic of continuous integration pipelines. If you attended Victor's talk, the one before me, it was basically about that. It's not really necessary for it to. It's not necessary to understand this to understand the content of my presentation, but it would be very useful to at least speak this language so that you can think of applications in your own project. And last but not least, we're using Perforce, which will become relevant in a couple of slides. One more time. Why are we here again? So I started talking about the commandlets, and I will talk about how to write one. But first, maybe we should decide if you actually should write one. Is this a good tool for your problem? Right. So, Unreal provides several ways of writing tools, and some of them are easier to use, like the ones on the left, and some of them require a bit more work, like the ones on the right, not a lot more work. On the left, we have Blutilities. These have a very low barrier of entry. They are very easy to use, at least from my perspective. They have quickest iteration time. For those who don't know Unreal, Blueprints is the Blueprint scripting language is the internal language based on visual programming inside Unreal, and it can be used to program your game logic, but it also can be used to program editor extensions. This is stuff that our technical artists are doing, that our technical designers are doing. You can do a lot in Blutilities, in Blueprint utilities. So these are editor utility widgets, asset utilities, any of that kind of extension. But you are limited. Not everything is exposed to Blueprints. On the other hand, you could move with that to C++. Everything that you can do in Blueprint can be done in C++ and more. Doing the same kind of editor utility widgets or asset utilities in C++ will allow you to get access to more low-level stuff, low-level libraries, modules inside of the Unreal editor. You still can keep decent iteration time if you use live coding. So you don't have to restart the editor most of the time. For us, this is the biggest slowdown factor. But there's still a problem. The problem is that the editor is running. And that has its advantages, obviously, but it also has some disadvantages. The editor needs to keep track of every asset, needs to load its own UI, etc., etc. So there's a lot going on. If you want a really raw, controlled environment, probably a commandlet is the way to go. It's also the best suited for running in the command line, obviously. Right. Here's some examples about how we use it in our company at 11-bit Studios. The one that was the biggest game changer, I think, for our dialogue pipelines was the audio import commandlet paired together with adding animation tracks to dialogues. This can very accelerate our process of importing raw audio files from AudioKinetic-wise and right into Unreal and assigning it to the proper dialogue assets and putting it in the proper folders, proper names, etc., etc. We also have a small commandlet that sometimes is run to make sure that all properties in Blueprints are marked as save game, to make sure that everything that has been done perhaps by designers or sometimes by programmers who forgot is properly marked as savable. Stuff that we're planning to do Well, first on the list, importing translations. So Unreal has its own translation management system, but it only is responsible for actually gathering the translated text and switching the language when necessary. But what you need is some way to get the text to the translators, get it translated, get it back. So you need an import procedure from that. We're not there yet, but it's certainly high on the list. Apart from that, we have some custom level checks that are currently run whenever you load a level, whenever you save a level. It would be great to be able to run them, for example, in the nightly build, so some forgotten levels also get checked on a regular basis. We have some ideas for analyzing dependencies between assets, but that one is perhaps a bit too involved to explain in one slide. So maybe let's skip that. All right. Finally, let's do this. So the use case that brought me here and actually set me on this rabbit hole, a couple of years back when we started the altars, it wasn't called the altars back then, we had an idea to migrate the system that we used in this war of mine into our new game, a system of gameplay events. And in our understanding, a gameplay event is something that represents an occurrence in the game. It's a very generic term, a very abstract term. So a gameplay event can mean that the player found a new type of resource, or there might be a gameplay event representing that somebody died, or I don't know, built a new thing. So these gameplay events, they have a class in some sense, and at runtime, instances of these gameplay events have other associated data, like a timestamp, like what was discovered, where it was discovered, etc., etc. It's a very generic solution to a lot of weird problems, in the sense that it's not the best solution, but it's often the fastest solution. So it was very useful during prototyping. Designers liked it a lot. They actually liked it a bit too much, and we ended up with thousands of them, which would be fine, actually. But the way we implemented them initially is we implemented these as blueprint subclasses. So each event needed its own subclass in the blueprint programming language, in the blueprint graph. That's not something Unreal is built for, especially due to the nature of the way we use them. Like, we ended up loading 90% of these at the start of each game. It was actually fine in the build. Like, the game performance was fine. The editor was the problem, because if you have thousands of blueprints and you need to compile each and every one of them, and that's single-threaded, this could take up to 2 minutes, 3 minutes, etc., etc. So we figured we should change it from subclasses to data assets being basically kind of a struct-based asset without any scripting, not needing any compilation. Now, last I checked, there's no easy way to do that. These are completely different things. There's no convert button in the Unreal editor. The reparent function won't work with this. So we need to write something own. Initially, I tried doing this inside the editor. The commandlet wasn't my first go-to, but turns out when there's a project of this size, the altar has like 40 people right now. So first of all, getting checkouts on all those assets was a problem. So I needed to rerun this all the time. And second of all, the editor would crash with out of memory. Trying to modify thousands of editors of assets at once is just too much for that. Maybe it's better in 5.1 now, but in 4.27 this was a problem. So I ended up writing a command line tool, and give and take a couple of weird bugs, we carried this through. All right, one more time. Let's do this. Let's write some code finally. But before you write some code, you need a place to put it. And the way I think about it, if you're doing it in Unreal, you probably don't want to put it in your game module. Unreal has this concept of modules. These are like DLLs for the editor, or static libraries for the game build. And they come in several types. We are interested in two of those types. One of them is the runtime module. That's the one that we think about as the game module. This is what goes in the game build. And the other type are editor modules. These do not go in the game build. And that's probably what we want, because why do you need a commandlet in the game build? I think it would technically work. I'm not sure what the use case is. You could write it, but the code that will be used by the commandlet will mostly be editor code from Unreal. But you can't have a dependency on editor modules inside a game module, because that won't run. Or maybe even won't compile, I don't know actually. Anyway, the solution to this is having a separate module for the editor. You could have one for your game, or maybe you need several. Setting it up is pretty straightforward. First you add the module in the project file, then you create a target file to specify what and when we're compiling, build file to specify how we are compiling, and in C++ you add an actual module class. I added the startup module and shutdown module functions. I don't think these are necessary, but you probably want them. One thing to keep in mind when working with commandlets, the loading phase. I set this to post default. If you set this to anything later, your commandlet will not be able to run. The commandlet framework does some discovery of, it runs through all the loaded modules at some point and looks for every class that implements commandlets, that inherits from commandlets. And if your module loads later than this process happens, then your commandlet will just not be found, and you'll proceed with a normal editor startup. It's probably not what you want. All right. It's a very nice commandlet. It's a hello world commandlet. Hello. All you need to do to write a commandlet at this point is just inherit from commandlet. A commandlet has a main function, like any nice command line tool. It takes a string for arguments and returns an integer to return whether it's a success or a failure. By convention, every command line tool returns a 0 to indicate a success, and a non-zero exit code for failures. Additionally, in Unreal, if there's any assert, ensure, log fatal, any this kind of things, this will immediately end the execution of the commandlet with a non-zero exit code. Next step is running it. It's pretty easy. Take your game, edit the properties, give it run equals name of the commandlet. Like the name of the commandlet class is up9 example commandlet, p9 being the code name for the alters. But you can just type in run p9 example and the commandlet framework will do the rest. I added no shader compile to suppress shader compilation. The documentation suggests you should do that because you don't want that during commandlet execution, but I never had any problems with that. This might be some kind of legacy outdated documentation. Commandlets are exist at least from Unreal Engine 3. So maybe stuff has changed, but the documentation is out of date. Okay, apply, close, compile, run. Hello world. This is the log output. That's the hello world that we did. Yeah, there you are. First commandlet, thanks for coming to my TED Talk. Nah, just kidding. Let's do something more. We're just getting started. Okay, so what were we actually solving? What was the problem that we were trying to solve? We were trying to convert assets from one type to another. We were trying to convert blueprint-based events to data asset-based events. Before we get to the meat of that, we first need to assemble some building blocks. One of the major building blocks in general in writing commandlets is parsing command line arguments. Thankfully, Unreal has us covered. There's this wonderful pass command line function. It grabs tokens, switches, and params. You can pass in values through the params array. You run them with a dash later on. I don't know if that's visible. But anyway, you run it with a dash, but then you look for it without a dash, and that's about it. You can use this to control behavior of your commandlet. But the next building block is much more interesting. We want to convert all assets of a certain type. So the first thing we need to do is find them. So how do we do that? Well, there's this dedicated module called the asset registry. This is the same thing that Unreal Editor uses to display the contents of the content browser, for example, or for the reference viewer to be able to display a tree of references. This is the single place that contains all the unloaded assets in the project, and it is authoritative on that. It might not be up to date on loaded assets or asset being edited right now and stuff like that, but for unloaded things, this is the place to go. It has a ton of information that it can access without actually loading the data, which might be super important because if you ever experience Unreal Editor loading times, you know what I'm talking about. Notably, it has access to asset tags, class hierarchies, references for the reference viewer, for example. You can listen for new assets being added or removed, and you can force the asset to load by just calling getAsset on the asset data, which is that thing. Little note over there on the isLoadingAssets function. Once again, the documentation suggests that at the moment of starting the editor, this might, the asset registry can be still in progress of scanning assets in the background. And if that's happening, you want to force it to finish synchronously, just in case. I never run into this issue myself, but well, I included it for completeness. Once again, it might be a case of outdated documentation. And apart from that, you can just ask it for, give me all the assets of this class. The P9 event is the thing we're looking for. And you get an array of everything. That's like instant. All right. So we have this for loop. We were going to convert some things. So let's add like a convert function here and start writing that. So I call getAsset to load the asset and give me the asset that's inside this file. So what is that thing? Well, what's under this pointer? Since the classes that we are looking at are blueprint subclasses, then each asset inside that we find here will be an instance of your blueprint. So these are separate concepts, right? So this represents a blueprint asset. This is not the runtime class of inside the blueprint scripting virtual machine. But this blueprint contains a generated class. So there's a one-to-one relationship. I think it's one-to-one. So this is the blueprint asset. The generated class is the blueprint VM class. Now they're not entirely separate concepts, they relate to one another. In particular, they share properties. So properties on the blueprint asset and properties on the blueprint class are the same. So if we want to modify properties in that blueprint asset, all we need to do is get the default object, get the class default object, and start changing its properties. Of course, some casts, because the get default object just returns you an object. And once you get the P9 event instance for the class default object, just change some property and save it, and you're done. And you change something in the project. We still need to write the save asset. We still need to write the save asset function, but that will be in a minute. Before we go there, there's one more thing I'd like to mention. There's another way that I've been using to modify properties like this. You could do it in the post-load function. Every object has that, as far as I know. It's a decent place because every time you resave an asset, it will get loaded. Post-load is called. It can modify some properties. It gets saved again. So this way, you're applying changes that you might want to apply. It's a bit clunky. It's usable in some cases where there's no easier solution. But let's not go into that one. Let's go into saving assets. Unfortunately, Unreal doesn't have a function called save asset. That would be too easy. You have to make one. You have to assemble it from parts. So the first thing you need is a package. Every asset has an associated package. What's a package? Well, let's ask Unreal documentation. So a package is a package. Thanks, Epic. Here's the way I think about it. A package represents a file containing an asset. This is the way I've been operating. So the package represents, the package object represents the file. The asset inside can be of any class, but the package is always a package. The code suggests that packages can contain multiple assets. I haven't personally run into this case. Maybe that's the case for like Unreal Engine 4 maps, levels, because maybe they have multiple assets, not sure right now. Didn't check that one. For our purposes here, one package, one asset. Back to saving things. We get the package, do some string manipulation to get the proper file name, make sure the package is fully loaded. The package must be loaded separately from the asset. Then we mark the asset that we want to save as dirty, pass in some wonderful flags. I will not go into these. These are an exercise from the reader. Then you call these two functions. Don't know why you need to call two of them. I didn't get to that. If I call only one, it breaks. And we're done. But there's one problem. There's one problem because this function fails. And why does it fail? What did we forget? Yes, checkout. We forgot checkout. Perforce doesn't allow us to modify files without checking them out. That would be too easy. Thankfully, Unreal Engine has a solution for that as well. It's another very important module, the source control provider. This is whenever you open the editor that's connected to Perforce source control, or I guess SVN or Git or any of the others. If you start editing it and save it, there's like a little pop-up that says checkout. This is where the data in that pop-up comes from. This is a generic abstract piece of code that is meant to handle any type of source control provider. This is the code for checking out in Perforce sanity check to make sure it's enabled, check if I can check out, do the checkout, make sure I succeeded checkout, get the state, and make sure it is checkout and I can edit and stuff like that. It's a bit boilerplatey, but it allows you to do all the source control operations that you might need. Okay, we got the save asset function working. One final step. One final step to get into converting assets. Well, we found everything, we can modify them, but we need to create new assets. We have almost everything that we need. We have the old asset, string manipulation to create the new path. For us, in our project, blueprints start with a BP prefix. We decided to have a dedicated prefix for the gameplay events, that's GE underline. Then you create a new package at the new location that you want. You create a new gameplay event, this is the data asset based one, inside the package new. So inside the newly created package. The first argument to new object is the outer, also known as the owner. It has to be inside that. Notify the asset registry module that the asset was created. This does not happen automatically. We could go on to saving the asset at this point, but I still wanted to copy properties. There's this wonderful function, copy properties from unrelated objects. I love it. It's like a static function on the engine singleton class. It's like totally random. But it does what I needed. We have objects that have properties of the same name, and it just copies their values. I probably could have written that, but it was funny to use that. And we're done. We're done for real this time, but still some closing thoughts. This is the stuff that I've been talking about. About the uCommandlet class and its parse command line function, the asset registry module, and how packages work, and a bit about properties, but there's a lot more to cover there. How we could save assets and how we could interface with source control, how you can modify assets, how you could create new assets. And as you might notice, there's only one point about actual commandlets. Like all of the other ones you can do in all other variants of Unreal Touring. So the thought that I'd like to leave you with is commandlets is just a front end. It's the code that you write underneath, the project-specific code, like the conversion that I showed you. Maybe you want it to be accessible by a commandlet. Maybe you want it in other types of C++ utilities. Maybe you want it in Blutilities or, I don't know, Python scripting in the editor. Think of adding a layer in the for tools, a separate common tools library that that doesn't depend on one particular front end you're using right now. So is it commandlets or anything else? Yeah, guess that's it for me.
Okay, thank you. Do you have any questions? Go. Nobody? Okay. So thank you very much.
Thanks.
For your presentation.